Work on calculating z-scores. Okay, so what we've currently done is we took a whole bunch of data, we ran it through, we found the standard deviation, we then set up our normal distribution curve, um, we checked to see how our data fared. It was not bad, and then we've redrawn the normal distribution curve here just because we want to do some z-score. So a z-score is equal to the data subtracted by the mean over the standard deviation. In our case, we were using that to represent our standard deviation there, okay, our sample standard deviation. So we have to figure out what's the point of a z-score and what does it do. A z-score will measure the area from the mean. Okay, so let's keep in mind the mean should be directly in the middle if it's normally distributed, which means that 50% of the data, so 0.5, is to the left, and 50% of the data, 0.5, is to the right of this mean. This curve is supposed to represent the area under this curve is essentially supposed to equal 1. Okay, that's what it's supposed to do. It's pretty hard to calculate this. You would use some calculus to do a area under a curve. Okay, but with that info, if we know that to the right of this, all of this is 0.5. In the positive direction, you could say, and then in the negative direction, this is also the area of 0.5, and it's usually known as negative. I shouldn't write that because it looks like together they are 0, but altogether is going to equal 1. Okay, a z-score is going to calculate how much data or how much area is taken up from the distance of the mean. So, what the heck do we mean by that? Let's say I wanted to know how many or what percentage of students have a grade that is less than 95. Okay, you'll notice that 95 didn't fall in our deviations. Okay, and if you recall from our standard deviations, 68% of the data fell here, 95 fell here, and then 99.7 takes up those 3 deviations. So we're looking for somebody who has a 95 or less than. Okay, so less than a 95. And that would probably fall somewhere like this. Okay, our 95 here falls right there. So that's our data set. That's our x. So to calculate our z-score, our z is equal to 95. Okay, subtract the mean, and the mean was our 81.8 from before, 81.8, divided by our standard deviation, and our standard deviation, I guess I should write that in here, was 15.2. Okay, so divided by 15.2 is going to be our z-score. So we take up our calculator. It's a pretty simple formula to follow there. 95 subtract 81.8 equals that number. That number, there you go, divided by 15.2 equals 0.8, around 0.87, so approximately 0.87. And the reason I rounded to 2 is because we're going to take a look on our z-score sheet. 0.87. So here's our 0.8. Okay, so we start on our left side. We have our 0.8, and we've got to go to 7. So here's, see how it says 0.07. We would kind of add these two together. So we would go across, and here we go. Here's our number. So what does this number mean? 0.3078. Okay, so let's go back. What it's saying is that from the mean, because remember this is being calculated from the mean, from here to 95 is, what was the number? I should memorize it. 0.3078. So 0.3078. Okay, what is that? Well, that's actually a percentage. Think of it like roughly 30.78%. Okay, that's how much data, or technically it's a measurement of area, falls in there. And that kind of makes sense, because if you recall, from here to here is 68. Okay, so half of that would be 34. So we're kind of like just missing that 4% in here in terms of area. Okay, so what really means this bar is probably a lot closer to this 97. Okay, but we were looking for how many people were less than 95. Well, we know that there's this, and everybody on this side of it is also less, correct? So that's another 50%. Okay, so technically, all of this is less than 95. So because all of that is less than 95, we have to take the value we had and we have to add 0.5 to it. Okay, so our z-score told us that we got 0.3078, and we needed to add our 0.5. So this percentage of data would be 0.8078, and you'd multiply that by 100 to figure out a percentage. Okay, so 80.78% of the class is less than a 95. Well, that makes a lot of sense, right? 95 is a really hard grade, so only 20% is higher. And actually, that's a huge percent to have above 95. Okay, I know these numbers look funny. What if it was the other way, and they wanted to know how many people have less than, let's pull another number out here. I'm just going to make it up. How many people have less than, I don't know, 60? Okay, how many people in a class have less than 60? We'll do the same thing, right? We build our z-score. We have 60 minus 81.8 divided by our 15.2. So we got to figure out what our z-score is with our calculator. And then we go check our chart. So we have 60 subtract 81.8 equals, okay, and divide 52.2. Okay, so I have a negative value. But because my z-chart only goes one way, and you might have a double-sided z-chart where the one value is already calculated for you, ours doesn't. So I'm just going to focus on the 1.43, approximately 1.43. So let's go back. 1.43, we have 1.4, and then we got to go over to 3. So here's 1, 2, 3. That's the data. 4236. So I know it's going to get a little messy up here. What this have just measured is the area between this number and the mean. So it just measured all of this. Okay. And it just measured it at, what was it again? 4236. 0.4236. In other words, 42.36%. Okay, so it just said that there's 42.36% or that much area between here. Let's say we want to know how many people are less than 60. Okay, same idea. But this time, well, less than 60 is only these people here. So because we know that this represents 0.5, and we just figured out there's 0.4236 in this area, we're going to take 0.5 and subtract this number, and that's how much area is going to be left. And that would be the percentage of people who are less than 50. So quickly do it. 0.5 subtract, so we get our z. We need our 0.5 subtract our 0.4236. 426. So our percentage or our area under the curve there would be 0.5, 0.4236, I think it was, right? Yeah. 0.076. Okay, so that's, in a percentage, 7.6% of the class. It's an amazing class, by the way. 7 point.
It's not mine.
Yeah, 7 point. What did we say? 7.8. Yeah. Percent have less than 60. So that means 93-ish or 92-ish% have higher than a 60. Wow, this class is a bunch of geniuses. Okay, and that's how you kind of deal with Z scores.